Hello everyone. In this video, we'll look at questions that arise when two or more related quantities are changing. The problem of determining how the rate of change of one of them affects the rate of change of the other is called related rates problems. So we are going to start with the first related rates problem, which is a hot air balloon. So let's read this question. A hot air balloon rising straight up from a level field is tracked by a ranger. So here is a ranger, and there is a hot air balloon that is rising. Now, just a quick check on certain things here. A vertical displacement is called y, and the horizontal is called x. So that's a common sense. So now we need to agree on these things. So this is basically y and this is x, okay? Now, let's go ahead and read. So tracked by a ranger finder 150 meter from the left off point. So this is a left off point, right? Now, it is 150, so this x is equal 150 meter, the distance between the ranger and the left off point. At the moment, the range finder's elevation angle is pi/4. This angle here is called an elevation angle, and it's equal pi/4. So if I will call this theta, so theta equal pi/4, and x is equal 150 meter. The angle is increasing, so this angle is basically increasing. It's like we started like this, and as while the balloon is rising, this angle is increasing and is rising, and the angle is increasing more and more, okay? So the angle is changing while the balloon height is changing. So the change in the angle is basically 0.4 radian per minute. So there is a change with respect to the time. This we call it d theta over dt. So d theta over dt means the change of the elevation angle with respect to the time equals 0.14 radian per minute. So how fast is the balloon is rising? So when I talk about how the change in the height of the balloon, we're talking about y. We don't know what's y, right? But we want to find dy over dt. So when I'm asking you to find the how fast the change of the distance over time, this is basically dy over dt or dx over dt. Okay, so in order to do this, we will look at the given information here. We know there's so many things and so many different ways of doing this question. I'm going to choose one of them, which is basically by finding a relationship between y and theta. That's what I want to use, okay? So I need to find the relationship between y and theta, and x too, of course, the three of these. We know that based on the trig ratios, we know that tangent theta equal opposite over adjacent. Now what is opposite here? Y. What is the adjacent? X. So I'm going to use this, okay? So let's do that. So basically I'm going to use tangent theta equal y over x. Do I know what is theta? No. Do I know y? No. Do I know x? Yes, it's 150. Now, what I'm going to do, I will try to differentiate this equation with respect to t, okay? So let's try to differentiate first tangent theta. So tangent theta is basically secant squared theta, and then the derivative of theta is d theta over dt. Don't forget that. Equal. This is basically equivalent to 1 over 150 y. That's how it is. So I can say 1 over 150 dy times y, which is dy over dt. Now, I know what is d theta over dt, right? And I know theta. So I could easily substitute. So secant squared pi over 4 theta multiply d theta, which is 0.14, equal 1 over 150 dy over d theta over dt. Now, by using the calculator or by multiplying everything by 150, this will cross out this and 150 will come in this side. So dy over dt will be equal to, if you put all of this in the calculator, which is 150 multiply secant square pi over 4 multiply 0.14, you will end up with 42 meters per minute. Another question about the balloon. So a balloon is rising vertically above a level. So there is a balloon that is rising vertically. So this is going to be y. Straight road at a constant rate. So when I talk about constant rate, so it's rising at a constant rate. This is, so I have y, I have dy over dt. It's a constant rate, 0.3 meter per second. Just when the balloon is 20 meters above the ground, so it's a 20 meters above the ground. This is y, 20 meters. A bicycle, when it was 20 meters above the ground, the bicycle moving at a constant rate of 5 meters per second. This is x. Now when I talk about constant rate, then this is dx over dt. Passing under it, how fast is the distance between the bicycle and the balloon? Increasing 3 seconds later. So I want to know how fast. So I need to find ds over dt. Okay? After 3 seconds, what happened basically? Y at the beginning was at 20. After 3 seconds, what happened? It's increasing, right? After 3 seconds, it's increasing. The rate of increasing is 0.3. So it's increasing by 0.3, by 0.3, by 0.3, right? So that's y. So my new y will be equal to 20 initially plus 3 multiply 0.3, which is 0.3 plus 0.3 plus 0.3. That's going to be equal to 20.9 meter. That's y. The bicycle started, x started here when the height was 20, and it started increasing. The distance were increasing by 5 meters per second. So after 3 seconds was 5, 5, 5. Every 1 second it goes by 5 meters. So we are doing x equal 5 times 3, and it's equal 15 meters. Okay. Now, if I know y and x, can I tell what is s? Yes, there's a relationship, which is by using the Pythagorean theorem. So let's move here and do this. S equal a square root of y squared plus x squared. Now, which is equal a square root. Y squared is 20.9 squared plus x is 15 squared. That's going to be equal to 25.73 meters. So let's put them here all together. So y is 20.9 meters, x is 15 meters, and is now equal 25.73 meters. Now let's go through the Pythagorean theorem again. So the hypotenuse square equal adjacent square plus the opposite squared. Now we are going to differentiate with respect to t. So 2s ds over dt equal 2x dx over dt plus 2y dy over dt. Now I want only ds over dt, so I'm going to divide everything by 2s over 2s. Now it's time to substitute. So ds over dt equal 2 multiply 15, dx over dt is 5, that's it, plus 2, y is 20.9 times y, which is dy over dt, which is 0.3, over 2 multiply s, which is 25.73. Final answer is rounded to the nearest one decimal place, 3.2 meter per second. And here we go. In this question, a 3.9 meter ladder is leaning against a house when its base starts to slide away. So what happened? Basically, a ladder here, that's an S. So S was 3.9 meter. Okay, now, is the length of the ladder will change ever? No, it will never change. It's a constant. Now, and the ladder was sliding away, so that's basically x. By the time the pace is 3.6, that's x. From the house, the pace is moving at a rate of 1.5 meter per second. So it's moving horizontally, that's dx over dt. Now, how fast is the top? Since it's moving this way, the top will move that way, down. Okay, slide down. So how fast is the top of the ladder sliding down? So they want us to find dy over dt. I don't have y, remember? Now by using the Pythagorean theorem, we can find y. So y is equal to square root of s squared minus x squared. That's going to be 1.5. So now we go here and use the differentiate. So this is going to be 2x dx over dt plus 2y dy over dt. And now, as I told you, s is a constant. S is a constant. It's the length of the ladder, and the length of the ladder will never change, so this is equal to 0. So the derivative of any constant, which is 3.9 squared, is 0. Now we need to find dy over dt, right? So, but we can substitute. So 2x is basically 3.6, dx over dt 1.5 plus 2, y is 1.5, dy over dt equal to 0. Now you can easily move everything to the other side or do the calculation whatever you like. Negative 2 times 3.6 times 1.5, when I move it to the other side, divide by 2 multiply 1.5. The final answer will be negative 3.6 meter per second. So the negative sign here represents that the ladder is sliding down. Okay, the ladder is sliding down. So guys, that's everything about the rate of change. There are so many other questions and you can practice, but then that's basically much everything. Let me know if you have any question and see you next video. Bye bye.